Hello, geography students. Welcome to your first notes adventure. I am going to be your guide, Mr. Meyer. Buckle in because we are talking about maps today, and let me tell you, no one loves maps more than the sky. Let's get going. So, of course, you have been in the Foundations of Geography folder. Thank you for finding that. We have scrolled down and we have clicked into 1.7 notes. And there you will find that right there. Make the copy for yourself in that assignments, and you will pull up that Google Doc, and it's going to look like that at first. It looks pretty blank. I apologize for looking blank. It copied weird on there. Just scroll down to the next page, and boom, look at that. We have our notes. Okay. Now, first little pro tip before we dig into these notes. If you want to uh, type over this really quick, you can do that and drag it, but that's kind of tedious, I think, especially on a laptop. Here's a quicker way. Double click each line. Double click, and then it automatically hides it. One more time, if you double click it, that will automatically highlight the line, and you can type whatever you want over top of it. All right, with that said, let's get going. First thing in our Foundations of Geography notes, we're going to be talking about the title. Now, of course, we start small. Here is my map, and the title is where you got to start. This tells you exactly what you're looking at, and here it says United States political. We're going to learn exactly what a political map is here in 1 minute, but by looking at that title, I know automatically what this map is showing me. If I don't know that, if I just dig in and start looking at this map, I might not find what I'm looking for, and I might waste valuable time looking. Keep in mind to always view the title. There are different types of maps. Titles can be helpful. Now we're going to move on to the key or legend. Usually it's going to be something that looks like this, a little box in one of the corners, and it explains what symbols on the map show. So, for example, if you're looking at a picture, or sorry, not a picture, a map of a park, or sorry, maybe multiple parks, then a tree will show you where the park is, fire will show you where a campground is, but sometimes it's not that easy. Sometimes you're looking at a map of roads and you have multiple colored lines running everywhere. You can guess what those lines are, but it would be much easier to look at that map key. That's one of the first things I do when I look at a map. I read the title and then I read the map key because that tells me exactly what those different symbols around the map show. If you look here, you see the political map key that shows you the difference between national capitals, state capitals, regular old cities, other countries, what an international border looks like, and what a state boundary looks like. So, even there, you see valuable information. Let's move on now to the compass rose. Compass rose is a pretty simple one. Let's see if I can find it on this map here I have in front of me. There it is. Sometimes it's just a little arrow like that, pointing north. Sometimes it'll have all the directions on it. Sometimes it'll have multiple points, and they all kind of look a little bit different. But the biggest part of it is that it shows you which way is north. Okay? By knowing which way is north, we know that the opposite direction is south. South is down here. We know that east is over here, and we know that west is over here. One of the best ways that I remember it is that north is always up top. Just always remember north above. I don't have a great way to remember that one, but a way that I always remember west and east is it spells we. So remember that west is here, east is here, it spells we. Also, you can always remember never eat soggy waffles. Or if you have a better way to remember it, let me know. Next, we move on to the map scale. And the map scale is something that's really important to remember. So think about a map as just the entire world, that actual area that's being shown, but it's shrunken down. Okay? So whereas in reality, it might show 50 miles. That 50 miles might be shrunken down into 1 inch. So we know here that for every 50 miles, That is just 1 inch. Every 100 miles in real life, in the actual world, is shrunken down to just 2 inches there on the map. If you look here at my map here, it is right there that you have the map key. So this much distance, that right there, is 200 miles. So I can put this anywhere on the map. So like Birmingham to Atlanta looks to be about 200 miles. And I can do that all the way across and be able to measure real distance unlike the actual world based off of that shrunken down distance. It's a ratio. It's a math term, ratio. I don't get into math. But know that you can take that little distance on a map, know what it says it is, because it has that conversion there. That much is 200 miles. And put that anywhere on a map, and that's the real distance. Now we're getting into lines of latitude. Latitude, fatitude is the way that I like to think of it, because, well, it's the Earth, but just a big fat ball. And if you go latitude, fatitude, that helps you remember that latitude goes around the Earth, okay? It helps give absolute location, but we're going to talk about that in just 1 second, okay? So, lines of latitude, they're horizontal. They go this way. But a great thing to keep in mind is that those horizontal lines stack on top and below each other, okay? So remember to keep that in mind, because the middle line there, that equator, is 0 degrees. We measure that as the 0 line. Thus, anything above 0 is going to be counting upward. And it's going to be going north of 0, right? Everything's going north. But you also have lines below 0 degrees, that equator, and those go the direction of south. Okay? Notice how it counts up from 0 this way, and then here we are at 0 again, and then it counts down from 0. All the way to the South Pole to the south, all the way to the North Pole to the north. Okay? So remember, these lines go this way, latitude lines go this way, but they stack on top of each other. Up to the north, labeled to the north, and then down to the south, labeled south. Let's move on. These are lines of longitude. Lines of longitude go this way, all around the Earth. Imagine like orange slices, right? So whereas with latitude, you could cut those into discs, with longitude, they're more like orange slices. Okay? Lines of longitude go cut like this. But if you look here on this little globe here, notice how they go this way. So here's a line, here's a line, here's a line, here's a line, here's a line. What direction are they going? They're going to the east and the west, right? I don't know if that's mirrored or not, but I did it the right way just then. East is this way for me, west is this way for me. So if each line is going this way, then they're going to be measured to the east and to the west. Notice that says 0 degrees longitude, 10 degrees longitude, 20 degrees longitude, and this is 10 degrees east, 20 degrees east. Why is it important that we label these lines of longitude, east and west, and these lines of latitude, north and south? Funny you should ask, because we're going to have to know which lines are which. There's going to be a 20 degrees longitude and a 20 degrees latitude. You got to remember that longitude lines are measured by east and west. You got to remember that latitude lines stack on top of each other, north and south. Let's talk about some important ones real quick. Big one with latitude is the equator. It is that middle line right there. Think of it as the belt of the world. And this equator is going to be the hottest places on Earth, anywhere on this line. Because anywhere on this line is going to be the closest point on Earth to the sun. So the Earth, if you can think of it as a ball, here's the sun. The equator is that middle part. Every part around it is farther away from the sun. The Tropic of Cancer is this line right here. It is 23.5 degrees north. By the way, the equator, it's 0 degrees latitude. It's that 0 point, by the way. But the Tropic of Cancer, it's 23.5 degrees north. And of course, the Tropic of Capricorn is 23.5 degrees to the south. Just know that between the Tropic of Cancer and the Tropic of Capricorn, you get the tropics. When they talk about the tropics, it is this area right here. It is halfway between the equator and the South Pole. Equator, South Pole, Tropic of Cancer. Now let's talk about some important lines of longitude. The first is the prime meridian, and that is 0 degrees longitude. Now, funny thing here. Whereas the equator is 0 degrees latitude because it is closest to the sun, it has that specific scientific reason. Prime meridian, we just picked the point. The only reason that the prime meridian is there is because that's where the people who decided to make a prime meridian were. That is the line going down where their tower was. So that's 0 degrees longitude. But it's important to know because every line going off the prime meridian increases. But let's think about this for a second. Can it just keep increasing all the way? Because then, at a certain point, it would keep increasing and like crisscross each other. It can't do that. So obviously, it's got to keep increasing till it gets to the very point behind me, right behind where it started. This point, opposite of the prime meridian, that is the international date line. It's called that because that is where the dates literally change. We can get into that. That's a little bit more in the weeds. You can ask me about that during our Zoom chats. But our international date line, that is 180 degrees longitude. Whereas the prime meridian, that's 0. Prime is where it starts. The international date line is the exact opposite. That is where the date changes. That is where it's 180 degrees longitude. I'm going to move on now to why we do this. Why do we have these lines, these confusing lines around the Earth? It is so that we can pinpoint to a T where something is. That's called absolute location. Absolute location tells you exactly where something on this Earth is. You, right now, watching this video, have an absolute location. And if you have a phone in your pocket, that phone has that absolute location. You are being tracked right now. Every one of us has a coordinates if you have a phone. All right? Geographers use absolute location to know exactly where something is. If you wanted to look up the Eiffel Tower in Paris, the pyramids in Egypt, they have absolute locations. But let's say you need to go somewhere more remote, somewhere where you weren't sure exactly where it was. Well, you would find its absolute location so that you could know where to go. Now, let's think about how you can pinpoint something. You have to have exact accuracy. So it is where those latitude lines and those longitude lines meet. So the absolute location of Kansas City would be 39.0997 degrees north. So that'd be the latitude location. And 94.5786 degrees west. That would be the longitude location. Because remember, latitude is measured north-south. Longitude is measured east-west. But think about this. If someone asks you, where is Sonic? Where's the nearest gas station? Where is Susan's house? I don't know who Susan is. You're not going to give them the absolute location. That would be bananas. You're not going to do that. You're going to give them a relative location. Relative location is simply saying it is north of here. All right, you want to go to Sonic? You have to go down 51st, and once you see the Quick Trip, it is to the west of Quick Trip. Okay, gives location by using the cardinal directions of north, south, east, and west. Remember, north, east, south, west. North is this direction, south is this direction, east is this direction, west is this direction. So example, Kansas City is west of Jefferson City, but east of Topeka. Okay, McDonald's is just south of the hospital and east of the ice cream shop. Relative location uses one point as the reference and says it is to the cardinal direction of that one point. All right. Kansas City is west of the Mississippi River. You with me? Let me know if you aren't by emailing me or sending me a chat in Microsoft Teams. I will be here to help you out. Now let's talk about the different types of maps. If you need to pause this video right now and just stretch a little bit, you can. I'll be here waiting for you. I don't want you to be powering through here because this is when I get to geek out. I love maps. Let's dive in. Let's start with political maps. Political maps, that is a type of map that I have right here. Here's a political map of the world. Notice how it is showing different countries in this map, all different colored. Notice how Europe has so many tiny countries here, this continents of Europe. That's all the tiny countries in Europe. Sometimes maps will zoom in on little countries like that and put it off to the side like they did there. Here is a political map of the United States. Notice the compass rose down here. Notice this map scale here so that we know that that amount of space on the map is actually 500 miles in real life. Here's the map key. It's real tiny. All you need to know is the national capital. That's it right there. There's not a lot going on with this map. There we go. And here's a political map of Missouri. Notice how this is showing different counties. There's Platte County, that's where we are. So political maps, it shows boundaries of different government bodies, okay? So think about that. Each country on that world political map had a different government. Each state in the United States political map has a different government than the other states. And even in Missouri, each county has different laws. We have a different government here in Platte County than they have in Jackson County. So, it can be broken down in various different ways. Those were 3 ways in which I just showed you there. Let's move on to physical maps. Physical maps, I think, are a little more pleasing to the eye. And notice how this map, it's got a small little map key here. You see where capitals are. But more than anything, I mean, it doesn't even tell you that there's a mountain right here. But I bet you a lot of you could just look at this and say, mountain, right there. They could look down here and say, that looks like snow and ice. They could look here and say, that's probably mountains. They could look there and say, probably either grassy or lots of trees. Heck, you could probably even look right here at this light blue and say, shallow water maybe? That's the point of this that's the point of this physical map. It shows you what the physical layout of the earth is, and it does it by the way that they draw the world. Here's another way in which they do it. This time, they do it by showing the elevation of the Earth with color. So this is still a physical map, but notice how like down here it's not white anymore, it's yellow, because over here is going to be the map scale. And this map scale tells you yellow is so-and-so elevation. Green is a lower elevation than yellow. But then once you get into the brown, you get a higher elevation. So the colors tell you how low or high the land is compared to where the sea is. Sea levels usually are a basis, and then everything else is higher or lower than that. That's another physical map. Here's another physical map of the United States. This does the exact same thing. Notice how the different colors show you how high in elevation things are. So green would be low elevation here. Kind of that light orange would be higher elevation, and then brown would be the very high elevation. And then this purple here is the highest elevation. And then here is just a fun one of India, just because I honestly love how India is shaped on a map. Okay, here is the political boundary of India, that line right there. Notice how that political line corresponds perfectly with this gigantic mountain range here. These are the Himalayas. The reason that India stops there being a country and there's a different country over here is because they drew the boundary where the mountains are. And an even cooler thing about India is that it is on a tectonic plate that is currently smashing into that mountain range. Pretty cool, right? You're going to learn about those different physical features specifically in the next assignment that you do with those landform dictionaries. So, physical maps shows the physical features of an area. It can include bodies of waters, deserts, mountains, grasslands. Really, it can show you anything depending on the physical map that you look at. And physical maps to me just look cool. I love looking at how our Earth is shaped because it's shaped so unique. All right. It can either be by different colors, shadings. It can be how they draw it. It can be the different colors that they use that the colors mean something. And it can include political information sometimes. Like, for example, here, actually, this one does not really include political information. But for example, this one did include some like country names. But for the most part, it shows you what the Earth looks like. Now let's go into road maps. Notice how I said that map scales can be important? Not map scales. Map scales are important. But the map key can be important. Well, it's kind of missing on this one, isn't it? It's hard for me to know exactly what a red versus a blue line means. Not to mention there's these pink lines here. But I've driven a car before, so I can say that the blue lines are interstates and the red lines are highways. Now, one reason that I really like road maps is because it can kind of tell you other things about the country. So just by looking at where these roads are going and where there's a lot of roads, you can tell where there's a lot of people. Up here is New York City. Notice how many roads are over there? Over here is San Francisco. Notice how every road goes into it? Same up here with Chicago. Same down here with Dallas. Same here with Denver. Follow this and then you can go to Salt Lake City. This would be a road map. Here's another road map of Missouri. Again, notice it's the same thing. All the big roads are coming out of St. Louis and are coming out of Kansas City. Road maps designed for travel, just major roads of an area. And maps showing a large area will only show major roads. So you won't get the smaller roads if you look at a map of the United States. You'll only get the big roads. Move on to topographic maps. This is going to be one that comes with the story. So let me show you some examples first before we give the notes. Here's a topographic map of Walden. Walden, I believe, is going to be right here. Notice how we got some hills here. Topographic maps can sometimes show elevation by the shading in which they happen. This could also be considered a physical map, but notice how you can see like the ridges along there. That's going to be the higher elevation. And then as it slopes down, here would be the low elevation until it slopes back up there. So again, notice how you can kind of see how the Earth is shaped just by looking at this topographic map. Here is another example. This one might look like nonsense to you, but think of this as like basically you got to find the inside of the circle. Once you find the inside of the circle, like this one, every other circle around the inside circle is going to be a slope. So this is the top. This line here for the next circle is going to be a lower elevation. This circle here is going to be a line that represents a lower elevation. And each concentric circle down is a lower elevation. So we can see here as it slopes down, and then notice how it's flat here. Just keep sloping down there, keep sloping down there. And you can go all the way until new circles start and they'll slope back up again, like here. Notice how it's sloping down, sloping down, sloping down, and then it slopes back up to this. So again, you can understand that, maybe not, but this is a topographic map. I, your geography teacher, was on a mountain recently reading a topographic map. I wanted to go from, say, like right here to right here. I saw that right there. It looks flat because I knew that it only increased whenever you went from line to line. Those lines show increases. So I tried going from here to here. But little did I think that it's still sloping up, right? It's hard to walk across a slope. So even I kind of still misread the topographic map. I think they're so cool to look at too. So topographic maps, they're maps that show the differences in elevation in an area. You can use lines or shading. The closer the lines are to each other, the steeper the elevation. Now for climate maps, different colors on these maps show different climates. So arid would be this part right here. Arid is another word for basically a desert. You can see Australia has a big desert in it as well. Tropical wet would be this green part. So notice how Madagascar has some green. Brazil has some green here. India has some tropical rainforest. Mexico even has a little tropical rainforest on there. And you can see that the subarctic and the tundra, those are really cold places. Notice how they're up north, away from this warm equator. Up north is where you'll find the cold Arctic temperatures. Here would be a climate map of the United States showing how much precipitation or rainfall it gets. The different colors you see there represent how much rain. And here's basically just another map of that same thing. This is how dry the United States was in August 15th, 2017. So climate maps shows consistent weather patterns of an area, and it consists of a normal map with colors representing the different climate types. Moving on. Pause me, by the way, if you're feeling rushed. Hey, I'm a video. Pause me. Thematic maps. This is the last one. Thematic maps are the fun ones. This is where we can map anything, and it's awesome. So, I bet you're wondering, where are the cat people at versus dog people? Here it is. So the more purple a state is, the more they like dogs. The more green, a state is, the more they like cats. Notice here in Missouri, we are more dog people. In Illinois here, where I'm from, they are more cat people. Darker the green, the more they like cats. Darker the purple, the more they like dogs. Again, you can map anything. Here is the population, right? Yeah, right? Oh, this is population density, right? So, population density would be how close you live to each other. The darker red means that people are living really close to each other. The darker purple means that people are living really far away from each other. So, there you're mapping a type of population. Here's the population under the poverty line. So, depending on how red a place is, that means that there is more. Basically less money. Higher poverty means people are making less money, and more green means that people are making more money, and there is less poverty. So you'll notice here in Kansas City, we have some poverty going on. If you go over here in New Jersey, not a lot of poverty. But depending on where you go, like down here along the Mexican border in Texas, you tend to have a lot of poverty. Here would be an election map from 2016 showing which states voted more for Trump versus which states voted more for Clinton. And here's a fun map that shows you whether or not states call it Coke, soda, or the blue means they call it pop. So this is a fun one for me because I grew up right here where we call it soda. If you grew up in the South, everyone calls it Coke. But if you grew up like up north, and apparently in Kansas City, I mean, I still hear people call it pop. And it depends on where you live. And this map shows it, which I love this map. And heck, here's even a map of football teams. You can tell it's kind of an outdated map because the Rams are still right there. The Raiders are still right there. But still, you can map anything. Thematic map shows information on a wide variety of different topics. And it distributes information across a defined area like a country or a state. Folks, that is it for my notes presentation. You did it. Hopefully this wasn't too long for you. Hopefully this wasn't too challenging for you. Hopefully you like maps just a little bit more. Email me with any questions you have on this. Thank you all for being such great audience members. So long.